All right, so thanks everyone again for your patience, and I'll just try and be as brief and concise as possible, because by 2 I have something else to do, so I don't know how I can squeeze everything I have to talk about in 1 hour 20 minutes, but I'll try my best. Like I said, it's a practical session, so I hope you have your laptops and just understand basically what we're talking about. So I'll go ahead and share my screen now. Okay. Please, can you let me know if you can see my screen? Can someone
I
just
see your screen.
indicate if? All right. Thank you so much. Okay, so basically, this is the summary of my journey. I finished college 5 years ago, 2015. I studied mathematics and statistics, but actually, the reason why I'm doing what I'm doing today is not because I studied mathematics and statistics. The reason why I'm doing what I'm doing as a career today is just a case of sheer curiosity. I didn't enjoy what I studied in school at all. I mean, there's the obvious Nigerian low quality education of the Nigerian university system, right? So there's a problem with that. Second, there was a very deep understanding gap between myself and what I was studying, right? So I didn't plan to practice. But eventually, the reason why I made a switch to data analysis was just simply a case of my final year project, where I worked with, I sparked a conversation with my supervisor on an interesting project topic, and she suggested actually for me to, to just take a look at what is happening in the north, as regards to Boko Haram insurgency. And so I just took a step and I tried to find some data sets. It was very challenging. I had to learn a lot of stuff on my own. But the whole experience just opened my eyes to the vast, how important it is to be able to, you know, understand what is going on with numbers. All right. So that was actually my first, encounter with anything data analysis, data science and all of that. Right. So 2016, I got my first job as a research analyst at Highnet Resources. It was a small company after my service here. I wasn't doing much of data analysis. I was just doing research, basic research, market entry studies, yeah, macroeconomic stuff like that. Then I got my second job as a junior data analyst at Retail Nigeria, which was a startup. So here I just put just for your information and just for you to understand my journey so far. At this point in 2016, my first job, I could only use basic Microsoft Office suite and SPSS. I had learned SPSS in college, and that was what I used for
Sorry, what's the
my
meaning of SPSS?
final project. So SPSS is, frankly, I don't know. It's an abbreviation, but it's more of a tool, a statistical analytical package tool. It's object oriented. So what that means is that you don't need any coding experience. You don't need any coding experience or software experience to use it. It's just a drag and drop kind of tool that you can use to analyze your data. But it has its foundation rooted in statistics. So you want to compute stuff like variance, standard deviation, and all of that. You don't need to use any formula. It's just a drag and drop, sort of tool that you can use for your
Okay,
statistical analysis.
I get.
Yeah.
Thanks.
So yeah. So 2017, when I started working as a data analyst in a junior role, I had to step up my Excel skill. I had to do a lot of learning on Power Queries, Power Pivots, pivot tables, some formula, some Visual Basic stuff. Because at that time in the company, the our major analytical tool was Excel, right? And another thing also with working in a real job is that you actually learn on the job, right? If you're in a job where you're not, it's not stimulating your learning, then that's exactly not the place to be. You should be in a job that that increases your curiosity and enables you to learn. And then yeah, so I started looking into programming, started using R actually. R is also a statistical software like SPSS, but it's more heavily reliant on the ability to code, right? So you need to learn how to write syntaxes and R and all of that. Then I moved upward towards the ladder as our team began to expand. I had to take on a more senior role. So I became the lead data analyst, and then I began to look into Python and Power BI. Now all of these tools was simply as a result of the need to expand what we're doing within the company. We had to expand our reporting. We had to, as we began to get more clients, we had to understand what they needed, and be able to solve those problems. And to do that, we had to look into other tools beyond Excel and SPSS and R. So I had to start looking at Power BI, Python, and all of that. And also at this point, I just decided that since I was going to continue my career as a data analyst. It was just it was normal for me to have another degree, a master's degree to what I had. So I enrolled in my MSc degree 2018. And then, 2019, I joined Nielsen as a data science manager. Basically, just using the tools I was using. And then on top of that, started looking into Tableau as well. So it's been a journey of learning, a lot of learning curves. I am not a master at using any of these tools yet. And so my point, the reason why I actually made this slide was just to make you understand that the fact that you don't know how to use a particular tool should not deter you from starting out. The fact that you're not so good at something it shouldn't deter you from actually launching into the deep waters and taking that first step. It's really, really important.
Sorry, I missed the beginning part when you were talking about. I don't know if you talked about what Nelson does, but I'm a bit curious to know what you guys do because I work with Survey here in Nigeria, and I tried. What we just do is just I answer surveys for them and I get paid. So I came across one survey you guys were doing. I saw your like name
Okay.
Nelson. So what is it
Okay.
about?
Okay. Yeah. Okay. So Nielsen is a data measurement company. What that simply means is they help, basically, they help brands, manufacturers, they help them to track their performance within the market, right? You have a lot of brands, whether it is FMCG or, they are wine and spirits, or, you know, um, whatever the brands are, right? Nielsen helps these brands to make decisions, to be able to understand exactly how their performance is within these markets, and also to evaluate how they are actually performing when you compare them with their competition. So I like to give a practical example. For example, we have Coca-Cola and you have Pepsi. These are very two giant global companies that pretty much they do the same thing, if you're being honest, right? The important thing for these brands is they want to be able to get market share, right? So what that means is they want a majority of the consumers to consume their products compared to the competition, because that way they're able to keep making money, they're able to keep investing in their products, and they do everything in their power to make this possible, from advertisements, to merchandising, to marketing, and all of that. All right, and to carry out all of these activities, they spend a lot of money, right? So a way to measure the effectiveness of all of these marketing activities, advertising activities, is to actually measure what is going on in the market, to understand who are the people buying our products, right? Where exactly are we located? Where are we out of stock? If you go to a particular shop today, is there a guarantee that you find a bottle of Coke? So all of these kind of metrics, this is what Nielsen specializes in, to help these brands to make decisions and to understand how they can improve their market share, to gain more shares and to make more money, basically.
Okay, thanks.
Yeah. So I work with the data science department in Nielsen. So what we do as data science is we design the methods of data collection and estimation, right? Like I was saying earlier, Nigeria, let's take Nigeria, for example. Nigeria is home to 200 million people. Let's say we have on average, I don't know, 20 million retail outlets. There is no way that Nielsen as a company or any company will be able to cover 20 million outlets. It's not possible on a monthly basis. It's just too expensive. It's too cumbersome. The logistics are crazy, especially in a place where Nigeria is a developing market where there's just a lot of bottlenecks, transportation issues, internet issues. The problems are too much. So the way Nielsen goes about it is to, rather than covering the whole population, they design a method to select samples from several locations. So, for example, they select maybe 1,000 stores in Lagos, 500 stores in Abuja, 200 in Ibadan, you know, and this number of stores account for each supermarket type, right? So whether it is a hypermarket like your ShopRite or Spar, to your neighborhood shops like Adide, to your local shops like the Apokis by your street. We design a sample that is robust enough to capture these different types of outlets. And then based on this sample, we're able to extrapolate what the population looks like. So extrapolate the behavior of the population. So that is what the data science department that's what we focus on. All right. So like I said, I was trying to explain earlier before Donya and Co joined. I was saying we have a very huge misconception in the data field, right? Where we think, oh, it's just data science and machine learning and all that. There's a lot of things, right? And I just want to spark your curiosity. I want you to take it upon yourself to do some research and see exactly what you can do. You don't have to follow the crowd to call yourself a data scientist or a machine learning. Now, this is not to discourage you, right? I just want to expand your mind, expand your scope, and understand that there are many aspects to it. Okay, so for example, there's data engineering, right? Data engineering is more of the infrastructure and the setup of data collection, right? Data comes from different sources, different variety, different frameworks, right? Data engineering is just the aspect that helps to connect data from multiple sources to understand exactly, ETL. ETL means extract, transform, and load, right? Database systems, Oracle, SQL, NoSQL, AWS, and cloud computing. Basically, to be able to collect data from different sources and to manage the pipeline of these data sources so that when you're extracting data, it's very seamless and it's very easy, right? And this is it's a very complicated concept on its own, right? Then there's also the business intelligence analysis part of data, which is simply a BI analyst has a specific industry knowledge. So, for example, maybe a financial analyst is somebody who is skilled, maybe studied accounting or is interested in money or, I don't know, stuff like that. And the person is able to use this knowledge and the knowledge of data analysis to combine them, right? So these are the kind of people that, build financial dashboards, profit and loss, returns analysis and stuff like that. Now you have a data analyst who is more of a generalist, right? A data analyst doesn't have to necessarily have a specific industry knowledge, right? It just needs to understand how data works, right? Understanding has a good knowledge of statistics, how to understand what data is saying, how to separate signal from noise. So what I mean by that is signal is simply, what the data is trying to tell you. Noise is simply, other things that are just confusing and that are just there. They are not necessarily useful for your analysis, right? Is someone saying something? Okay. All right. Then you have a data scientist who is more technical actually. So the data scientist is more of the machine learning person, more of the statistical programming person, more of the person who has an advanced knowledge of statistics. They understand the concept and the mathematical equations behind those algorithms that you write, right? A lot of people that call themselves data scientists are not data scientists. They just have an idea. They just know how to code. That's it's the truth, but it's also very sad. Like a data scientist is not just someone that codes. A data scientist is someone who understands the mathematical equations and variables behind your algorithm. So they're not just coding, they're not just copying and pasting code. They understand exactly what they're trying to achieve and all of that. Now, having said all of this, there are other fields related to data that are also very important that I feel people don't talk about enough or people are not aware of. You have data storytellers, you have data journalists, you have data visualizers, you have data architects. Now, like I said, in your free time, I would like you to just take it upon yourself to do some research on this other field because you might find something interesting. Now, if you're somebody who you've tried to code or you've tried to learn, a lot of machine learning concept and you just feel it's not meant for you, but you still want to do something related to data, then you could be a data storyteller. Now, just to explain data storytelling, it's just simply, creating a narrative out of your data set, right? So I give an example, how, how Donald Trump won the election, and there are a lot of statistical analysis as to why he won in some counties and how he won in some states and some swing states and all of that. A data storyteller would make a very compelling and just a very beautiful narrative out of that experience in such a way that a layman can read what he's saying and understand it without without needing any further explanation, right? If you're somebody who is able to bring stories to life, able to explain stuff in a simple and concise manner, right? And you're also somebody who is very curious, you want to have a career in data but you don't like to code, then you could actually look into this kind of stuff where you just write stories about data. You understand exactly how to extract insight and you're able to communicate this with a layman's audience. I think this is very important, right? So it doesn't, everything shouldn't be about coding, even though it is important that I mean, if you learn it, if you're very good at coding and you understand mathematical equations, all fine and good. But if you're somebody who you genuinely believe this is not for you, but you would still like to have a career in data, then you could try data storytelling. You could be a data journalist, right? So these data journalists are simply guys who work with you know journalism organizations to help them to crunch their numbers, right? It's very similar to data storytelling, but it's just that in this case you're actually working with reporters. You're working with the media. You're trying to communicate to a very large audience, as regards a particular issue, right? And then you have the data visualizer who specializes basically in graphics. You are somebody who would like to express the beauty of data in pictures, in interactive charts and all of that. So this could also be a career for you. There are people that actually do this full time. There are people who they've made a very solid and splendid career out of this. These guys don't have an extensive knowledge of coding or machine learning algorithms, but they can make data come alive by creating visuals and all of that. So I hope this is interesting for somebody here who can relate to what I'm saying. All right, so I'll just try and speed things a bit because we're really running out of time. So here I just put just a brief snapshot of what is in common here, right? So you have um, you have a data analyst, you have a machine learning engineer, you have a data engineer, you have a data scientist. Now, these are some of the important things. Now, if you see um, the circles that are very deep green, are talking about the core tools that are very important to which of these career fields, and the one that is light green are the ones that are less important. So if you're looking to become a data analyst, well, you need to have the solid knowledge of programming tools. You need basic data visualization and communication, data intuition and statistics. When it comes to data wrangling, machine learning, software engineering, and all that, uh, that should not be a focus. However, if you want to be a full-fledged data scientist, you need to have a hang on all of this. So this is not to scare you; it's just to prepare your mind and help you understand what it takes to be a data scientist. It's not just about coding. Like if it's just about coding, then you're going to shoot yourself in the leg. Uh, so know how to code, but know exactly what makes you tick and go all in. If you want to become a data scientist, then know that there's a lot of things involved, a lot of things you need to learn. You need to just keep learning, never stop learning, right? But there are other things that you could actually do, right? I mean, you could start from somewhere. You can start from being a data analyst, and then you could work your way up until you learn that things, and then you're able to bring yourself up to scale and up to industry standard. So all of this is just to give you a background on um, on breaking into the industry. Now, the other things I also want to briefly touch that I didn't, put as notes into the slide, and it's about, how exactly can you break in. I would suggest, if you're looking to break in, that a lot of you are probably familiar with some of the things I'm about to say. You need to do a lot of personal projects. You need to do a lot of collaborations if you can collaborate with other people who are already in this field, so that you can learn from them. You can build your network. Never stop learning. Try new stuff. Build new projects. Then most importantly, have a portfolio website. It could be just a site where you have a link to all your projects, or it could be a GitHub account where you have a repository of your codes. It could be whatever, but just have a place where all of this is readily available, right? This is a very valuable way to show that you have experience in whatever field you're choosing to do. And I feel like this is just the best way to break into the field. Just have a variety of products, a variety of portfolio, rather, of things you've worked on. Yes, so I think that's about that. Then moving on. So now I'll just start talking about what we exactly have what to do, which is introduction to some of these concepts, introduction to statistics and probability. But so far, does anybody have any questions, any observations?
No, the flow is good. We're
Okay.
following.
All right. So brief definition of statistics probability. Like I said, I want to keep it very simple, very straight to the point. No formula, no calculations, right? We're going to get to the practical aspect of it, where we actually apply some of these concepts to real data sets. And after then, we discuss maybe an assignment, just to get your hands dirty as well. But just for the sake of this conversation, we had 2 hours. So I wanted to keep it as short, precise, straight to the point. And the reason I'm saying this is because I don't want you to take what you see here as the whole domain knowledge. There's a lot of things behind this that you need to learn on your own, but just to make it clear, from somebody who has some experience working with these concepts, right? Just to make it clear to you in layman terms. So just some definition of statistics. Statistics is a science that actually deals with collection, analysis, interpretation, and presentation of data, right? So you don't just collect data, you don't just collect numbers, you don't just, if you look around you, there's data everywhere, right? Now the science of making these data sets make sense is just statistics. So whether it is something as, oh, what time am I waking up today? Have I been consistent with waking up at a particular time every day of the week, to more complex stuff like, oh, how many billion people are starving in the world, or how many babies are born every minute, right? So anything that involves collection, analysis, interpretation, and presentation of data is simply data analysis. And more importantly, statistics. Sorry, I meant statistics, not data analysis. More importantly, statistics tends to work more with historical data. Right. There's a part of statistics that deals with future current data, but a, a large part of statistics deals with historical data, with what has been collected in the past, right? Whether it is time series or historical data. Probability, on the other hand, is the likelihood of the occurrence of an event. So probability tends to look more into the future, right? And that's why a lot of machine learning algorithms, a lot of machine learning techniques are heavily dependent on probabilistic equations, because you're trying to predict the future, you're trying to predict the next point given historical data, right? You hear concepts like binomial binomial probability. Yeah, you hear something like you hear some stuff like Bayes theorem and stuff like that. These are probabilistic concepts that are employed into machine learning just to help us to predict future occurrences, to learn from the past and then predict the future. So basically, in layman terms, that is what this means. Now, so let's just go on to building intuition from data. Now, in statistics, intuition is simply understanding the concepts and scientific methods employed behind data science and behind statistics. In other words, to properly make data-driven decision, you must understand the behavior in the data itself. Now, if you go by the layman definition of intuition, intuition is like a knowing, just a knowing in your mind, a very strong knowing. You can't explain why you know it, but you just know it, right? You just know that, maybe you know that tomorrow, when tomorrow comes, you are going to wake up by 9 a.m., even though you have no proof of that, but you just know, right? But in statistics, we don't work like that. We don't work by just your gut feeling. You have to understand why something is happening, which is why statistics is so important. It's so important. You have to be able to explain why something is behaving a certain way. You have to understand exactly why things are the way they are, right? Statistics helps us to understand distance. So simply building intuition is just understanding the key concept that we use to understand how a particular data set or a particular variable is behaving. And some important things to discuss are exploratory data analysis, distribution types, decentralized limit theorem. I'm going to go for that. We're going to do some practical sessions, so it's all fun, believe me. All right, so like I said, coming from intuition building, a very key component, or part of what we want to discuss is exploratory data analysis. Now, exploratory data analysis should actually be the first step in whatever data set you're analyzing. We have the practice, or I would say people are trained to just, when they want to work with the data set, to just get right into it and start plotting charts and graphs. If you want to really understand how your data is behaving, or you want to have just a basic idea of what is wrong with your data, you have to carry out EDA, right? To be able to develop an understanding and to be able to explore relationship between variables. Now, some key concepts of exploratory data analysis include measures of central tendency, which is mean, median, mode. You have measures of spread, which is your range, your skewness, your cortices. You have outlier detection, you have box plots, and you have 5-number summary. Okay. So very quickly, I'll just go through some sessions here. So I don't know if you guys have access to this link. I shared the link with doing, I don't know if she shared with any of the team members, where you have all the data sets that we're going to be using in this practical session, just for your perusal. I don't know if you have access to this link. If you don't, please let me know so that I can just copy it and paste on Zoom right now, so that you can also have access to it and you can follow as we go on.
I don't have access to Zoom.
Okay, so let me just share right now. Okay. Um, can I still see my screen?
Yeah.
Okay. Please let me know if I lost, if you guys are lost or you have any questions. Please, it's supposed to be interactive. You're supposed to ask questions if you don't understand. Okay, so just give me a sec, please. Trainings. Okay. Just clear this. All right, can you guys, is my screen still visible?
Yes.
Okay. All right, so here, just to understand, just to give you an introduction into exploratory data analysis, I will just work with this very simple straight to the point data set. This is a data set showing the information of animals and species in zoo. So you have in our first column, you have the zoo name, and you have, so if I sort this, you have the kind of species in each particular zoo. So for example, you have Badlands Zoo, you have tiger, lion, monkey, penguin, polar bear. In City Zoo, you have tiger, polar bear, penguin, monkey, lion, and all of that. And then you have the number of animals, for each of the species. And then on top of that as well, you have the number of animals vaccinated, right? And then you see the
Yes, finances.
hello.
Okay, don't worry, don't worry.
Okay,
Sorry.
all right. So they have the most recent vaccination date. Now, what does if I was supposed to start working on this particular data set, right? What a lot of people would do usually is to, okay, what is the number of animals that were vaccinated? And then I'll plot a bar chart, or I'll just do a table and say, okay, at this particular date, 20 animals were vaccinated. 10% of them was lion, 5% of them was tiger, 50% were penguin, and all of that. Now, that is not the ideal way to go about it. The first thing you should do is to understand exactly what your data set is saying. Right. So, for example, I want to understand exactly what is the on average, what is the number of animals that were vaccinated on average, right? Like, so if somebody asks me, okay, on average, what is the number of animals that were vaccinated, then I can, just do a mean, right? I can do a mean of, all right, how many animals were vaccinated, and I can see my result is 5.48. But because I know that this this is actually numbers, it's not decimal. You cannot vaccinate 0.48 animals, right? So you understand that it's just five. You understand that it's just five. Okay. Now, how about, okay, so this is just an example. All right. So, like I said, EDA is just looking to understand exactly how, what is the story behind that data set, what is the behavior. And to properly understand that, there's something we call, like I explained that you have what you call measure of central tendency, measure of spread, and all of that. So when it comes to measure of central tendency, there are three particular components. You have the mean, you have the median, you have the mode. A central tendency measure is just simply telling you exactly how far apart each data point is, right? How far apart are they from each other? That's just what measure of central tendency is telling you. Now you can visualize this by just saying, okay, if I plot this on, say,
I'm sorry, yours can see it now.
sorry.
I thought your screen was frozen before because I was not seeing anything. I can see it now.
Okay, but you can see it now.
Yeah, something popped up. I think so. A chat box popped up.
Okay, but can you see my screen now? Is it very visible?
Yeah, it's visible. It just felt like it was frozen because you were talking and like it felt like you were doing stuff, but it was not reflecting on your screen.
Okay, all right. Sorry about that. Okay, so yeah, so back to measures of central tendency. Please, can you mute your screen? Can you mute your mic? All right, thank you. So back to measures of central tendency. Like I said, a measure of a central tendency, your mean, your median, your mode, is just explain exactly how far apart your data points are, how far are they from a particular converging point, which is the middle, right? So I can just simply visualize this by, sorry, give me a sec. Okay. Yes, so I can just create a pivot table rather. So come here. Okay, and then I have my number of animals. Okay, so now if you look at this is what I call a frequency distribution chart, right? So not to confuse you, all right, this is just saying how many times, if you look at this number of animals, how many times just four appear, right?
Sorry,
How
I
many
just
times
want
just
to
four
ask.
appear?
Is anybody seeing? I'm not seeing the screen is frozen here. Is anybody seeing the screen?
I'm not seeing anything either. I'm seeing like a black box.
Yeah, I'm just
and
seeing the
then
black box
a
and your
different data set.
data set. All you were doing since we're not seeing anything.
Okay, just give me a second. Let me stop sharing. Can you guys see my screen now?
Yes.
Yes.
Okay, sorry about that.
You're right.
All right, so let's carry on. So basically what I was trying to do was to understand exactly the frequency distribution of these numbers. So what I mean by that is, ideally, I would like to know exactly how many times each of these numbers appear, the numbers in column D, right? So what that simply means is, of all the, of these numbers, tigers, for how many times does the four appear, right? So I can just create a simple pivot table. And I created a pivot table by just selecting all of these and click on insert and then click on pivot table here, right? So, okay, let me just do that again. So in case you didn't get it. All right, so I select all of these. All right, and then I insert the pivot table. Okay, and then so I already selected my table range. And then it says choose where you want the pivot table to be placed. So I can choose a new sheet. or I can choose this particular sheet that I'm using. So I click on existing sheet and then I choose the location. I can just put it below here. All right, and then I click OK. All right, so I have my pivot table here. I have my, my pivot chart fields. So I want to see the number of animals, right, and the frequency with which they appear, right? So here I just go to value feed settings and then count, and I click on OK. So what this is simply telling me is that the number one appears 2 times, the number 2 appears 7 times, and number 3 appears 3 times, and then all of these 6, 7, 9, 13, 16, 18, 22 appear just 1 time each. This might not be very obvious to me, so I can go ahead and, okay, let me remove this first. I can go ahead and create a chart from this and insert, and I just create a simple bar chart to see, okay, so here it's very clear to me. It's very clear to me that the number 2 has the highest frequency, followed by number 5, and then followed by number 3, right? The other numbers, just one. I can even take it a step further and say, okay, which exact animal has the highest number of frequency, right? I can just come here and instead of number of animals, I can actually put the animals themselves. So I put species on my rows and I put species on my column, and then I do a count. Yeah. So actually, what this means is that I have actually five species. So I have the same number of species everywhere. So this is just me understanding exactly what it is to say. Now, there's something I also want to bring to your attention here. Now, this particular chart type shows exactly the frequency distribution. We call this a frequency. You can call it a bar chart and all of that, but giving you the explanation and the background of what I'm trying to do. I'm trying to know exactly how frequently each particular number occurs. So this is the frequency distribution chart. Now, as you go on in this exercise, you also be able to understand exactly how to interpret a particular distribution type, whether it's a normal distribution or it's the distribution that is skewed to the left or skewed to the right, or all of that. Okay, so let's keep this somewhere. All right. So now going to our EDA. I was talking about exploratory data analysis earlier, and what I was trying to say was that your exploratory data analysis helps you to understand exactly how far apart or how close together the data points are, right? Now, to conduct an exploratory data analysis, we do something that we call the 5-number summary, right? Your 5-number summary is just your median, okay? Your median, your first quartile. So let's call that Q1, first quartile. Your second quartile, let's call that Q2. Your upper bound, let's call that UB, and your lower bound. I'm going to explain each of these, don't worry. All right, now you have your median. So to understand the concept of median, I will first of all try and explain. I think everybody knows what mean is. Mean is simply the average of a particular, the sum of a particular line of numbers divided by the count of those numbers. That's mean, right? So, but median on the other hand, median is not like that. Median is calculated as sorting your list of numbers from the least to the greatest and then picking the middle point, right? So why exactly are we using median as a measure of central tendency as regards to mean? Why is the median preferred? The median is usually preferred because the median is robust to outliers, is robust to figures that are outrageous. So for example, just to give an example, you're just thinking aloud, you have, let's assume this is a data set, right? You have two, right? You have 1 billion, or yeah, and they have 4, 5, 6, 7, 8, 9, 10, 11. Okay, right? If I were to calculate the mean of this number, I can guarantee you that my mean is going to be a very large number. So if I do an average, of this Okay, I can see that my mean is 666,671. Now, looking at this data set, this is very strange. If I am not trained to carry out an exploratory data analysis, and I just go ahead and start working on my data sets and I start producing insights, I'll just come and say at the end of the day, okay, the average of this number is 666,671. Meanwhile, there's something going on here. There's an extreme case of an outrageously large number that I am not accounting for. Now, I am unable to know this. Now, I can easily detect this with a small data set. Yeah, this is just a data set of, say, n is equal to 15. So at a glance, I can understand what is going on. But what happens when you have a data set that is, I don't know, 1 billion entries or 1,000 entries or 500? It's going to be difficult to detect this kind of issues firsthand, which is why you have to get into the practice of conducting a preliminary EDA to understand what your data set is saying. Now, on the other hand, if I do the median of these numbers, the median on the other hand is going to be a very different story, right? The median of this number is telling me, okay, this is mean and this is median. The median is telling me that, out of this data set, the median of these numbers is 5. Now, because of the way the median is computed, what Excel has done, or any analysis tools, any analytical tool you're using, what it does is to rank these numbers from the smallest to the largest and then picks the middle value. That way, you're able to understand exactly, what the data point is saying, how far apart they are from each other, right? And you can see from here, this is between 2 and 8, and it's choosing the middle value to be 5, which is a much better, summary of the behaviors between each number. Is, it can give me an example, a middle value of this particular number set, rather than the mean, which is saying 666,671. That's not even the case here, right? So this is why when it comes to the 5-number summary, we prefer to use the median, because median is more robust to outliers. Is more robust to outrageous numbers. When I say outliers, I just mean outrageous numbers that don't seem to make sense in relationship with the other data sets or the other variables, right? So that is the median. Then we have something that we call quartile, Q1, Q2, Q3. Now, a quartile is just simply, think of your quartiles as, percentages. So for example, you have, this is 15. I mean, our NA is 15. Now, just think of your quartile as this. Your first quartile, is 1/4, is 1/4 of 15, right? Your second quartile is another 1/4 of 15. Your third quarter is, another 1/4 of 15, right? And then your last quarter is another 1/4 of 15. So quartiles are just a way of segmenting your data sets into 4 equal parts, right? And you're going to understand and see the, the importance of this concept as we go on. It helps us to also understand exactly how far apart or how close these data points are, right? So Q1 is just simply the first quartile. This is Q3. Q3 is the third quartile. Then the upper bound and the lower bounds are just simply the extremes, that we use to detect outliers, right? So as regards to this data set, right, let's now conduct a proper EDA of this data set, right? And carrying out this EDA, we use the 5-number summary. Let me just put it here, 5-number summary, right? So carry out. Okay, so now we have to find each of these values, right, to be able to understand exactly what our data point is saying. So our median is simply, you can just write an Excel formula, which is just simply is equal to median, all right? And then you select all of this, number of animals, and then it calculates it for you. So here it's saying my median is 4. All right. Now to calculate my first quartile, there's a function in Excel called the quartile executive. So that's Q. You can see it's a quartile.exq. All right. And then if I follow the syntax of the Excel formula, it says array. So array is just simply my data range. So I select this. Okay. And I'll click on comma. And then you see these other options here. Right. I click on array, then it says quartile. So Excel gives me the option of choosing which of the quartiles I want to calculate. First quartile, which 25% percentile, median value, which is 50th, which is the second quartile, or the third quartile, which is 75%. So here I'm calculating my first quartile. So I choose 1. All right. And then calculate it for me. So here it's saying that my first quartile is 2. Now we do the same thing to calculate my third quartile. So that would be just the same approach. Quartile Excel, quartile exec, my range, and then third quartile. All right. Then now before we calculate my upper bound and lower bound, there's something called interquartile range. Let's just call that IQR. Now the interquartile range is just simply the difference between your third quartile and your first quartile. So it's just simply this minus this. That's my interquartile range. Now to calculate my upper bound is simply described as the value above which any other number that lies in it is an outlier. Now to give an example, just to make it graphically clear in your head, this is what we're trying to achieve, right? You have this thing you're seeing right there is called the box plot diagram, right? You have and the basis of the box plot is to understand exactly how it's to measure central tendency in our data set, like how far apart they are, right? So and also to detect which values do not make sense, that is outliers. Now here, your middle value is called your median. Your Q1, which is the 25th percentile, is the end of this box here. Your Q3, right, is the other end of this box here. And then the distance between your Q1 and your Q3 is called your interquartile range, or IQR, right? Now your upper bound, which is the bound above Q3.
Sorry, I'm not seeing the box. Oh.
Hello?
Is it just me? Sorry,
What are you saying?
The box plot you're explaining.
What are you seeing on your screen?
I'm just saying your mouse is at book 2. That's where your mouse pointer is right now, at book 2.
Okay. Okay, can you see my screen now?
I can see it now.
Yes, can see it.
All right, sorry about that. So, but are you guys following? Is it clear?
Yeah, it's clear.
Okay, thank you. So here, I'm just trying to explain what we're trying to calculate. I'm trying to show you graphically how it looks like. This is a box plot. So ideally, it's supposed to be in something like this, right? Where you have, I'm trying to explain. This box is just trying to tell me how closely my data sets are related or how far apart they are. Now, this line here is the median, where my mouse is pointing to. You see the median, which is the middle. And then you see my first quarter, which is the end of this box here. And you have my third quarter, which is above the median here. And then you see the distance between Q1 and Q3 is called the interquartile range, which is the IQR. And then you have the upper bound and lower bound. Now, the upper bound, as the name suggests, is simply your data point above Q3, right? So your upper bound limit is simply the limit above which any data set that falls above that limit is regarded as an outlier. And then your lower bound is simply any data set below this particular lower bound is also regarded as an outlier. And then from there, you can be able to understand and make a decision and investigate for those points that are above the upper bound limit or below the lower bound limit to understand exactly why these values are too high or too low. And that can actually lead you to an interesting insight as well. But if you don't carry out an EDA, there's no way you'll be able to, to understand, that you have such data points in the first place. You just assume, that everything is well and good. All right. So, sorry. I think every time I have to keep sharing. Okay, so going back to our previous slide. Okay, so now let's calculate our upper bound. Now, the formula for calculating upper bound is simply Q3, right? So I do equal to Q3, right, plus 1.5 times our interquarter range. Okay. Now, similarly, we calculate our lower bound. Our lower bound is simply, instead of Q3 this time, we use Q1. So we do is equal to Q1 minus 1.5 times interquarter range. Just double check that. Okay, this is correct. Then double check as well. Q3 plus 1.5. Yeah. Okay, so now we have a 5-number summary. Now you might not be able to appreciate this 5-number summary, right, until you put it in perspective with your data set. Now, from the previous chart I showed you, I was explaining that an outlier is simply a point that exceeds your upper bound or your lower bound. So any point that is above our upper bound, any point that is, any data set or any data point that is below our lower bound is regarded as an outlier, right? So how does that relate to our data set of number of animals here? Very simple. So here, I simply want to find out of this data set, which is an outlier, which number does not make sense in relationship to the other data points. Now to do that, I can just do a simple formatting here. Now in other tools like Python or R, there are other ways to do this, but we're working with Excel here because I feel like this is very basic and anybody should be able to do this, right? So here I can just do a conditional formatting, right? Where I just do new rule, and then I come to format cells that contain. Now I do cell value. Now remember, I've already selected my range of values that I want to format here. Then I do cell values, right? Greater than, I select greater than here. And then here I choose the value that I want it to be greater than. So I select my upper bound here. Okay. Now what I'm simply saying is I'm telling Excel that look at these values in this cell range I've selected. Check if it is greater than this particular value, which is our upper bound. Now, if the value is greater than our upper bound, format this value with this particular color, right? So here I just go to format, and then I choose a particular color, and I click on OK. Okay. So what Excel has done for me is it has shown me which of my particular data points.
Well, I can't see what you're talking about.
Hello?
Because like your screen is froze, your mouse, your cursor is still on book 2, and that's just it. It's nothing showing or popping up.
I'm seeing it though. I'm seeing it on my screen.
Okay, so some people can see my screen and some people cannot see my screen. Hello, if you can see what I just did, the formatting I just did, please can you just indicate so we know we're on the same page?
I could see it.
Okay, so sorry, who said he can't see it?
That was also.
Yes, I'm still seeing the same screen as the one you were talking about, the zoo data.
Okay. Can you see my screen now?
Yes.
Hello, can you see it now?
I think your screen is frozen. I don't think it's from my end.
How about the others? Because I just stopped sharing and then I
I'm seeing
reshared.
your screen
Yes,
clearly, Sha.
I
I
can see
can
yours.
see your screen.
Also, I
can
think
see
it's
your
from you.
Yeah, also, I think it's your network.
I'll come back in. Okay.
Yeah, so maybe you can just drop off and then come back on. All right. So I guess we can carry on. All right. So like I said, what I've just told Excel to do for me is to format which of these data points falls above my upper bound. And you can see here, I can see numbers 16, 18, 27, right? Then I can also do the same thing for my lower bound, right? I know we don't have any number that's below -4, but let's just do it for the sake of understanding, right? So I just do the same approach, select my data range. I go to conditional formatting, new rule, format only cells that contain. Now, instead of greater than, I do less than, all right? And then I come here, I select my lower bound, okay? And then I also format and I say, okay, if it is below my lower bound, format it, give it a blue color, all right? Now, obviously, we have no blue color because we don't have a negative number. So,
Sorry. So if we're working with a very large data set,
yeah.
we want to select a particular color, do we always have to drag it down to the
No,
end?
no. You can just click on the column itself here, and it's going to select everything for you.
Okay.
Yeah. Any other questions? Okay. So just to carry on. So like I said, in case of when you have now this might not seem so obvious. You can if you're somebody who has very high attention to detail, you might detect this, just by looking at your data set. But if you have like large numbers, you need to make a habit of doing this so that you can understand what is happening. Now, as a data analyst or as a data scientist, you can begin to probe questions like, why do we have lots of monkeys and penguin in Banda Zoo, right? um is there a particular reason why we have these particular high numbers, right? And also in Park Zoo, why do we have a lot of penguins compared to the other animals? So this can be some of the questions you can begin to ask to understand where data is telling you, right? Now, the point of when people deal with outliers, right? Most people treat outliers as bad things, like, okay, if this number is too high or too low, then it's a bad number, then I can delete it from my data set so that I don't have problems. Rather, outliers can be a very interesting way to understand exactly what is going on, right? For example, let's just take something practical. If you're trying to measure temperature of, say, every day of the week for the past 5 years, and then you do an exploratory data analysis, and you see on some days that you have very high temperatures. It's an interesting way to understand why you have this kind of very high temperature on this particular day. Say, what happened? Is it that, is it carbon emission that's causing it? What exactly is going wrong? These are some of the very powerful tools, of a powerful contributions of a data scientist or a data analyst to solving data issues and to generating very meaningful insights is by asking these kind of questions. So that's 5 number summary. Now, if you want to just freestyle a bit and want to plot a box plot like I showed you earlier, it's just something straightforward. You can just come here and insert all charts, and then if you have Excel 2016 and above, I think you will have a box and whisker, and then Excel just straight up plots it for you, right? So this is just a box plot, simple. But you don't need to plot a box plot every time. You can just do the simple stuff and flag whatever data points just to make sense and all of that. So that's all I can think of now for data analysis, for exploratory data analysis. And like I said, you should carry this out each time you're looking at a fresh data set to understand exactly what is going on. All right. So let me go back to our presentation. Just give me a second. Okay, so so now let's discuss the measures of spread, range, skewness, kurtosis. All right. Sorry, just give me a sec. Okay, so this is just for me to explain, for you to understand exactly what your frequency distribution chart can tell you. Sorry, my laptop is hanging. Some very okay. Oh, damn it. Okay. So remember earlier when I showed you a frequency distribution curve, right? So this is the frequency distribution curve is very important to tell you exactly how, the symmetry within a data set, right? How symmetric it is. And this is a very important concept that you need to understand, which a lot of people don't follow. People just assume that it's not important, but it's very important. Now, take a look at this. First of all, can you see my screen? Can you see this chart I'm showing? I'm showing a
Yeah.
chart. Okay, thank you. So first of all, take a look at this chart, right? First thing you can notice that there's a particular pattern to this data set. You have a middle point, right? That is higher than the left side and the right side. Just graphical explanation. I'm trying to be very simple. So the middle point is higher than the left and the right side. Okay. Now, what this frequency distribution curve is showing is that there's a lot of symmetry in these data sets, right? Symmetry in the sense that when you actually plot our numbers and then you do like a frequency distribution, you can see that our mean and our median converge to the same point. So in this particular data set, you almost don't have a case of any outlier, right? Your median and your mean at the same point. That is, if you take the average of the numbers or the average of the data set and you take the median, remembering our conversation on mean and median, you get the same value or almost the same value. Then it shows that your data is symmetry. And then your left side mirrors exactly what is going on the right side. Now you also have some cases where you have complete opposites, right? So your data can be skewed either to the right or the left. Now in this particular chart, you see that the graphs or the bar chart are highest on your left side, and then they begin to dip as you go to your right side, right? Now, this is right skewed. It just means that the tail of your values is to the right. And in this particular data set, there's no symmetry. It means that your data is concentrated on one side more than the other, right? Majority of your values are concentrated on the left side, on the smaller numbers, and you have the bigger numbers, a few, right? So a very, how can I say this? A very typical example is income levels in Nigeria or income levels in any country. You always know that the 1% or the top 1% have the highest numbers, right? So here you have probably Aliko Dangote, you have Otedola, you have our politicians. I don't know if you have any child of any politician here. No apologies to you. All right. So you have, some of these numbers here, heading top, like these guys have all the money, and then you have the rest of the population. The list is endless. You have the other 95% who, are not earning so much. That's a very perfect example of a skewed data. Now, data can be skewed either to the right or to the left, right? So skewed to the right just means that you have a longer tail on your right, and skewed to the left means you have a longer tail on your left. Now, how is this important into carrying out into understanding, into having data intuition? How is this concept important? It is important because for you to work with any data set, you must assume that it follows a normal distribution, right? And what is a normal distribution? A normal distribution is simply a distribution that follows this pattern, which is symmetry, right? Like the one that we have here. That's a normal distribution. Any data set that you plot to the frequency distribution chart that follows this pattern here, we assume that it follows a normal distribution. Now, it's important that you understand this, because if your data doesn't follow a normal distribution, then you need to do some statistical adjustments to your data. You can't just start working in your data set like that. You can't just begin to conduct analysis or make assumptions. It has to follow a normal distribution. You have to ensure that it is symmetric, right? Because it's when you ensure that it is symmetric, that is when you have actually made corrections for your outliers, you have made corrections for your irregularities, and and what doesn't make sense about your data set. It doesn't mean you're trying to make your data perfect. It just means you're trying to properly prepare your data in a way that whatever analysis that you draw from it is going to make perfect sense. That is why this is so important. Now, this is where the concept of the central limits theorem comes in, right? Let me just go back to our slide and then share the, yes. Okay, so now this is where the concept of the central limits theorem comes in. The central limit theorem is very important in statistics and states that when a data set is large enough, greater than 30 records, the data will approximately follow the normal distribution and fall in line with the bell curve. The more records there are, the closer the distribution comes to being normally distributed. While the data itself may not be perfectly symmetrical, you can still use the normal distribution as the basis for your statistical equations and calculations and assumptions. So what this simply means is that when you have a data set that is greater than 30, you don't need to go to the stress of checking, oh, is it a normal distribution? Is it not a normal distribution? Because most times you're going to encounter your data set that doesn't strictly follow the normal distribution. It can, it can be skewed a bit. It can look like it's not perfectly bell-shaped. But what the central limit theorem is enabling us to do is that we make a very big assumption that once our data set is greater than 30 records, once n is greater than or equal to 30, then we can assume that it follows a normal distribution. So that means that we can carry on with whatever kind of analysis that we want to carry out with our data sets without worrying whether our data is normally distributed or not, right? But however, if our data is less than 30, then the central limit theorem does not apply. Now, this is very useful. This theorem is very useful in the practical business world, because most times when you work on data sets, you're going to be handling n is greater than or equal to 100 data points normally in an ideal business setting. So this is very straightforward. And then if anybody asks you, why did you do this kind of analysis, are you sure it's correct? You can use this theorem to ascertain the validity of your statistical analysis. I feel like, is this clear enough? I mean, do you have any questions on this particular theorem and its application?
Yeah, it's clear.
It's clear, okay. All right, so we've discussed, I think we've covered pretty much everything. So these are the different kind of distribution types. There are a lot of them, right? There's chi-square, there's Weibels, there's binomial, geometric, all this. You don't need to disturb yourself with all of this. The normal distribution is what we are most importantly following after, right? So I think we've covered spread, skewness, 5 numbers from a box plot data detection, okay. Then distribution types, then central limit theorem. I think our time is, I think it's almost 2. Okay, I'll just quickly wrap this up. I'm not sure we'll be able to work with Power BI today. I don't know if that is possible. But we'll just carry on. We have just 5 minutes left. But like I said, I would like to also discuss some take-home assignments, just to get yourself busy and to get your hands dirty on 1 or 2 exercises that you can work on. Okay, so very quickly, we look at correlation. So correlation is just simply to understand relationship between variables in your data set, right? So very quickly, let me just go over to another data set I've prepared to explain the concept of correlation. Give me a sec. Okay. So here, I also have an interesting data point here where I have simply I'm trying to this data point is just a data set of patients' records on drug usage and blood pressure and their weight as well. So ideally, when you have data sets with a lot of variables, variables are just simply different points, different measurement points in data sets. Here, our variables are blood pressure, drug usage, and weight. Those are variables: weight, drug usage, and blood pressure. Blood pressure in this case, you have systolic and diastolic blood pressure. Now, it's possible that I want to observe relationship between a variable and another variable, and the correlation actually helps us to do that. Now, there are different kinds of correlation. You have a positive correlation, you have a negative correlation, and you have no correlation. Now, a correlation is positive when you have value, when your correlation coefficient is simply value that helps you to check the strength of your correlation, right? To give you some perspective on that, let me just quickly show you this here. So from my screen here, you can see your correlation is a strong positive correlation when you have your charts of those variables when it is something like this, right? It is strong. And then this shows a weak correlation. And also conversely, your correlation is negative when you have a very strong negative chart like this, and then it is weak when it is something like this. Now, there's something we call correlation coefficient. Your correlation coefficient is just a single value that tells you how strong or weak your correlation is. Now, if your correlation falls between 0.5 and 1.0, it is regarded as a strong positive correlation. Whereas if your correlation falls between 0 and 0.5, it is a weak positive correlation. On the negative aspect, if your correlation falls between -1 and -0.5, it is a strong negative correlation. And then if it falls between -0.5 and 0, it's a weak negative correlation. And if your correlation is equal to 0, then it means that both variables that are trying to compare the relation between them, there's no relation between them at all. Okay, so a very, like I said, practical example to demonstrate this is just to look at this blood the relation between weight and drug usage, right? So here I can just come here and graphically understand what is going on. So if I come here and I go to just plot a line chart here, right? This chart is showing me, okay, let me just put some labels so it's clear. I'm sorry. Okay, so here, if you recall the previous chart I showed you, if you see something like this, from indication from these charts, exactly, I can see it's a strong positive correlation. I can see it actually, but I can also use my value to determine my R value to determine actually the actual value, and then use that to check if there is some relationship between those variables. So to do that, Excel makes it very easy for me to find a correlation. I can just do is equal to correl. Okay, that's a function. And then I click on this array. all right, that correlates drug result against weight. Against weight. Okay. Now, what this is telling me is that my correlation value is 0.9%. Now, recall from previous charts, when you have a correlation between when you have a correlation between 0.5 and 1.0, you have a strong positive correlation, which is exactly the case in our example, right? So here, sorry. So my correlation coefficient is 0.91, which means there's a very strong relation between drug usage or drug dosage and weight, which means that the higher the weight of a patient, the higher the dosage of drugs that they use. This is very important in understanding if you have a lot of variables in your data set and you want to understand if there's any relation between them, anything that you should be aware of, then it can help you to drive very deep insight into some of these variables. So this is pretty much straightforward. There's the other part of evaluating relationship between variables, which is called regression, but that's much more complex, where you have to have an equation that predicts each value that you had to your data set and see exactly where it falls into, right? So it's already past 2. I think we can hang it here. Is doing Salah still on the call? She's not on the call. So I think I can hang it here, and then I can share with you the Google Drive that contains each exercises, and they can just practice on what we've learned today. And I'll also put the link to the Power BI dashboard, where you can actually download it and play around with it. I don't know if that's fine with anybody, or you have any suggestions.
Yes, Victor, that's great.
Is it possible that you can hold on that session about the Power BI? Because that was really what I was mostly interested in. I was looking forward to that actually.
Yeah, I mean, it depends on everyone actually. I mean, is everybody okay spending extra 30 minutes to go through that, or you would like to discuss with your admin? I don't know, your rep doing, and then she'll fix another session where we can probably go into that. So that depends on. It's not dependent on me. It's dependent on what you guys are saying.
Would 30 minutes be sufficient for it? We wouldn't mind.
Yeah, if the 30 minutes will be sufficient, I don't think I mind. Toyi, let's know, sir. What do you guys think?
I don't mind either.
Okay. All right. That's fine. That's fine. That's fine then. Just give me a sec. Let me just close this. Give me a sec, please. Close Excel. Okay, so Power BI is I don't know what your understanding of Power BI is, but Power BI is just there are a lot of business intelligence softwares, data analytics, data visualization software out there. There's Power BI, there's Tableau, there's ClickView, there's Looker. There's a couple of them. You can also use Excel for data visualization as well. But it's just the strength of Power BI is in data modeling and collaboration. So what that simply means is if you want to combine or connect data from different sources, Power BI is very good at integrating data from different sources. So I'll just share my screen again. Okay, here's Power BI. All right, this is how the interface looks like. I don't know if you have it installed, but it's pretty much easy to install. Just go to your Microsoft Store on your laptop and then search for Power BI and then install it. Yeah, so that's pretty much easy to set up. Now I have prepared a particular data set. I did just some practice on some data set I found online on a financial dashboard. I have included it in the link that I shared with you earlier on Zoom. You can go ahead and view it, but let me just show you just the dashboard itself, how it looks like. This is just the PDF, not just give me on see rents, see fashion